The one that we're supposed to be using the integral test. Notice that this series goes from 2 to infinity. We can't have 0 because of that n would cause division by 0, and we can't have 1 because natural log of 1 is 0, so we have to start this one at 2. So we will need to integrate from 2 to infinity, and I'm going to use x instead of the letter n as my variable. And so integrate this. So this sort of goes back to chapter 7, techniques of integration. The first thing to always try is a u substitution. Well, and you should let u equal whatever's inside another function. Well, I've got these two guys are inside the fraction, but then if I keep in mind the derivative of the natural log of x is 1 over x, then that right there is going to be the du if I let the u equal this natural log of x. So u is equal to the natural log of x. The du will be 1 over x dx. And this has 1 over x, and it has dx, so that's exactly what we need. So this will be integrate. So this is the u. That means we've got 1 over u. And then this part, 1 over x dx, becomes du. And what I do is just leave the limits off until we're done integrating, until we have the x's back. So go ahead and integrate this. It's going to be the natural log of u. You might think we need to put plus c, but we're going to have limits. So since it's a definite integral, you don't have to put plus c. So this is going to be the natural log of x, nested natural logs. Evaluate it from 2 to infinity. So when you substitute infinity, we're going to have what's the natural log of when x goes to infinity minus the natural log of 2. Well, natural log of infinity means follow the natural log graph out to the right, and you'll see that it goes up forever. So this part right here becomes natural log of infinity, which then in itself is going to be infinity. Since this is just a finite number, this is some small decimal number, that's not going to change the infinity idea. And so it diverges. So this one diverges, therefore this one going from 2 to infinity diverges. As I mentioned in the previous podcast, number 72, the natural log function goes to infinity, but very, very slowly. Well, if it's then the natural log of the natural log, that's going to slow it down even more. So we did prove, yes, the sum is going to go to infinity, but it's going to do it very, very slowly. But it still diverges.